Review. Over the next few minutes, I'm going to go over some of the vocabulary and some of the thought process behind Unit 1. The Unit 1 packet can be found on Canvas. You can download it if you do not have a copy, or you can print it. Okay, let's go ahead and kind of look at what some of the main areas are that we're talking about. The biggest thing that you need to make sure you understand this concept is if your data is collected poorly, you cannot continue a good study. So this is why we are trying to so hard concentrate on how to collect our data. So first of all, let's look at not only what things are, but the purpose of them. The one thing about the AP test is that you're going to have to know the purpose sometimes in the multiple choice questions and sometimes in the FRQ questions. But the whole idea of randomization is to reduce bias, because when you randomize, you are trying to literally try to get two equal groups. Because if I or how many ever equal groups or something, if I randomize a group of people and I have a group of 100 people, let's say, and I randomly choose 1, 2, 3, 4 in here and 1, 2, 3, 4. These two groups should look fairly the same. I should get a good cross-section of the population. With randomization, I want you to remember there is a random sample and a random assignment. And you have to decide, or you have to put if it's a random sample or a random sample, or random assignment. A random sample is how you choose your data randomly. So it would be, which we're gonna go about here in just a second. And random assignment is randomly assigning treatment. So I guess I'll just put this like this: treatment assigned randomly. So this one would be, if this is, I already have these people in my treatment, I might do heads or tails, flip a coin. Heads is treatment, tails is no treatment. This person maybe is heads, let's say tails, and then heads. So these are the people with the treatment, and the other person is with the placebo, but those were assigned randomly. With random sample, there's a bunch of them, and we're going to go through them here in a moment as far as how I'm choosing my sample. All right, so I have types of bias. And the bias, I've got volunteer response bias. That's the reason that it causes bias is because I have volunteers and that's it. And I have not chosen my sample. And volunteers, people that volunteer typically have an emotional connection to the question, or there's a reason that they want to respond. So therefore, the problem is that tends to change the direction of what the true population would be in their direction of response. Remember, that's what bias is when you are leaning one way or another. And with the AP test, you need to make sure you talk about which way the bias that you see in the problem is causing to lean and why. Okay, response bias is when you give a response, it's just not the truth. And it's not the truth because either the wording of the question or it's the participant is put in a situation that they feel uncomfortable to respond. It's either this one or this one. Those are two reasons that it cause not truthfully. You can obviously read this and you can see what the publisher put as far as other examples. Under coverage bias is when you leave a group out, but you're representing them, you're representing the entire population. So for instance, if I ask Dawson High School students, if I was serving Dawson High School students and I ask, what is your favorite movie? And let's say I had 100 males and 10 females that happened to be in my study. Well, obviously there's an overrepresentation of males and an underrepresentation of females. So this would be an undercoverage for females. And it may actually, change my survey if I had a more equal representation of gender. Selection bias is the opposite, where selection bias would be where now I have an overrepresentation of one. So on this particular, the one right before would be the males are studied more, and so that would be selection bias because I have more in one particular group than another group. So you could call this example selection bias or undercoverage, but the reason that it would be selection bias versus if I did different races, let's say race A, race B, race C, race D, and race E, and let's say I had 100 of these, and then I have 10 of each others, this now would be selection bias because I've got more of this particular one versus under coverage if I was doing races A, B, C, D, E, and I have 10 of this and then 100 of E's. You see now race A is less represented. So this would be clearly that this is under coverage and this is selection versus the male-female one could be either one. To avoid bias, you're going to randomly select your subject. This is to avoid bias, and that's the whole idea of what we're doing. We're reducing bias or experimental units from the population we're studying, and there are 4 basic systems of random selection we're doing. Simple random sample is also known as SRS. I understand that these also have that acronym. However, these are not SRS. Only simple random sample is SRS. And this is where you have an equal opportunity of being chosen in every single person has an equal opportunity, or whatever I'm doing, experimental unit, every person has an equal opportunity being chosen in each group of whatever size that I've done. So what that means is if I have 1, 2, 3, 4, 5, 6 people and I'm going to randomly choose 2 of them, and let's say I randomly choose by either putting them in a hat and shaking it, because the shaking is the randomization. If I don't, it would be convenient sampling where it's convenient to choose the one on top, or a random number generator or random number table or rolling a dice, all kinds of different things you could do. But let's say I do one of these random methods and I get 2 and 5 are my 2 random numbers that I have chosen. And this means that I have each number had an equal opportunity of being chosen, and each group, which is the second one of size 2. This one, that's what's group of size N. The group of size 2 had also an equal opportunity of being chosen. Stratified random sample is when I have the same thing, what I'm going to do now, 1, 2, 3, 4, 5, 6, where this is the odds and this is the evens. So step 1 is to put groups in a strata. And the strata are homogeneous stratas. The reason they're homogeneous stratas, if you notice, homogeneous means the same, and that means the people around them or the experimental units around them have some sort of commonality. 1, 3, and 5 are all odd. 2, 4, and 6 are all even. And so that's step 1. And then step 2 is going to be that you do an SRS of each strata. And those people or experimental units are those are the people that I've chosen to be part of my group. So if I randomly chose 1, 3, and 5, and I actually chose 5 to be in my group, 2, 4, and 6, and I chose 2 to be part of my group. Ironically, you can see that I got the same thing as I got above, but that just was by chance. Systematic random sampling, if we do again 1, 2, 3, 4, 5, 6, let me just go 7, 8, 9, 10 just so I can demonstrate it a little bit better. If I randomly choose somehow of where I'm going to start, so it's a random start. So I random start at 3, and then I'm going to go up systematically by the same number. So then let's say I went up 2. So I've got 3, 5, 7, and 9 are maybe the 3rd person, the 5th person, the 7th person, the 9th person that walk through the door are going to be part of my sample. Cluster sampling is, I always like to call it a slice of cake, because the cake, this may be, I should do actually the color that it may be, strawberry. Then this may be chocolate. And this may be vanilla. And this slice of cake tastes the same of any slice of cake, but it represents, if you take a bite of the whole thing, it represents what the entire cake tastes like, and it tastes so good, I'm going to eat the whole thing. So cluster, if I do cluster, I've got, let's say cluster 1, person A, B, C, D, cluster 2, person A, B, C, D, cluster 3, well, maybe I should have done this, A, B, C, maybe this has a couple D's in it, I don't know. 4, A, B, B, C, D, maybe I'm going to put some more people in the class. Anyway, let's say A are the athletes, B are the music people, C are people that have a job, maybe that's their main thing, and D is kind of just our academic people or whatever. And if you notice, each one kind of looks really similarly. They're not identical, but they have a similar makeup. So for cluster sampling, the first step you're going to do is you're going to do an SRS, a simple random sample, to choose the cluster. And I should have put, sorry, that's really step 2, because the first step is that we're going to put them into clusters. So the first step is you're going to put in heterogeneous grouping. So this was different with stratified. These were homogeneous groupings, and I had something similar in these groupings where these were the same. Now you've noticed these groups, they don't have anything that are the same, and like a piece of cake, that piece of cake looks similar to the entire cake itself. So these are all snapshots of the population. And second, so first of all, you put them in heterogeneous groups. Secondly, you do an SRS to choose the cluster. And so if I did an SRS, that's a simple random sample. Let's say I chose 4. And if you notice, I'm coloring the whole thing, because then the last step is that you're going to sample all in the cluster. So if I were to choose 2 of them, if I randomly chose 2 of them, 1 and 4, I would do all the people in 1, and all the people in 4 would get my sample. Okay, next for experiments. So for experiments, strata that we just talked about is to surveys and observational studies, as blocking is to experiments. So in blocking, it's similar, because you're blocked into homogeneous groups. You look around you and you have someone that's really similar to you. Maybe they're the same height as you, the same gender as you, they have the same color eye, something similar. And the whole purpose of doing that is to reduce variation, because in blocking, what you do is you end up putting people in a block. Let's say that we decided to do it by age, and I have under age 10 here, and then maybe between 10, 11, and let's say 15. And those are the 2 different groups that I or let's do 5 to 10. And let's say I was studying, let's say that I was studying, not under 10, but I was studying how they responded to different commercials. And I noticed that younger kids tend to respond a little differently, so I decided to put them in block, and then I would do this would be my random assignment. And I would randomly assign them to treatment 1 or treatment 2, treatment 1 or treatment 2. And so then what I'm going to compare are the 5 to 10-year-olds to the 5 to 10-year-olds, the 11 to 15-year-olds to the 11 to 15-year-olds, so that I get a comparison to, again, reduce variation. Because if I have a 5-year-old and with a 15-year-old asking how you respond to a commercial, because they have different interests, different intellect, they're going to have a huge variation in the responses. But if I put them into groups that are people that are more similar to their age, and I may even want to break these groups down even better, because I find that the blocking needs to be even closer, because I'm getting too much variation than I would. Okay, so a blocking, remind you of size 2. That's called matched pair. And that's when you're getting someone that has a really similar quality as you. If you're studying something, for instance, the one that I just did above, maybe I decided that I'm having too much variation, so I'm going to block a 15-year-old with a 15-year-old, and then a 14-year-old with a 14-year-old, and a 13-year-old with a 13-year-old, or something like that. And so I'm getting people that are similar in age, and then I'm going to give this one treatment 1 and this one treatment 2, and then I'll compare the results, and so forth and so on. So a matched pair is a blocking of size 2. The best matched pair is yourself, if you can. But obviously on this one, watching the commercials to see how you respond, I can't do that, because I want to see how you're going to respond to it. Now, if I had 2 separate commercials, I might be able to do that in that case. Okay, so the control group is, the whole point of a control group is to reduce the effects of confounding variables. So let's jump down to what confounding variable is. When there's an uncertainty, which variable is causing the effect, so you have to do which one, both to receive credit, you have to talk about how it confounds the data that relate to the results to both groups. So for instance, if I say do better grades make me happier, and that's what I'm studying, Or is it sleep that makes me happier? And I didn't control sleep, right? And so sleep would be my confounding variables. Does sleep give me better grades? Does sleep make me happier? This is a confounding variable, and it's relating to both of them, so I'm not sure. Jump back to blindness. The point of blindness is that it reduces bias, and you could have double blind or single blind. Of course, double blind is when the evaluator and the subject does not know what the treatment is. Single blindness is when the subject does not. Okay, generalizability. For generalizability, you can generalize results when it's been randomly selected for population. For cause and effect, for that, cause and effect, you can have cause and effect when you have a random assignment. Experiments versus observational studies. The only thing you have to say for that is if it's an experiment, there is treatment. And then I want you to state the treatment. If it's an observational study, you'll just say it's an observational study and there is no treatment. All right, I hope this helped. Go ahead, and I do have a video also for the next part of the free response. So do these free response questions and the multiple choice questions. All right, thank you so much.